All right, welcome back to statistics. We are going to cover our final section on binomial distribution here. I'm going to see if I can't go a little bit faster with this one, so that might be helpful to look at the previous video where I'm explaining a bit more. But let's just get right into it and see if we can finish these four problems. Okay, so let's share the screen. There we go. Put this aside and let's just get ready to go here. So, looking at the next problem, it says, what should I buy? Okay, a study conducted by a research group in a recent year reported that 58% of cell phone owners use their phones inside a store for guidance on purchasing decisions. So you might look at reviews or stars or what price things are, etc. A sample of 16 cell phone owners, like everybody now, is studied. Round the answers to at least 4 decimal places. Great. Okay. What is the probability that 7 or more of them use their phones for purchasing decisions? Okay, so let's just write down some information here. We have an n, right, is equal to how many people? 16 cell phone owners. Okay, we're going to say that we have a 0.58% chance of success because we're looking for number of peoples who use their cell phones to assist in a purchasing decision. All right, and then we have to figure out for this thing. Okay, so part A, we have what is the probability that 7 or more use their cell phones on a feature? So we want 7, 8, 9, 10, 15, 16, right? Which ones don't we have? We don't have 0, 1, 2, 3, 4, 5, 6. So since we're looking at a collection, specifically this one, we're going to use our Binomcdf, okay? And the CDF, the cumulative function, will go from 0 up to a certain point. So what we're going to do is we're going to calculate these probabilities. Okay, we'll call that Y. And we know that this collection plus this collection of probabilities has to add up to 1. Okay, so the one we want, right, that's the Y, is equal to 1 minus whatever we get in here for this amount. Okay, so that's what we're going to type into the calculator, is whatever this amount is going to be. So we're going to be Binomcdf, right? We have 13 possibilities, or sorry, 16. We have 16 possibilities. Okay, with a chance of success of 0.58. All right, and we want to go up to 6. Okay, so what is that? Here's my calculator. So we're going to go from distribution, okay, CDF, we want CDF. Okay, we want 16, comma, 0.58, comma, 8, 6. All right. So this collection here, this was 0.0805, 0.0805, rounding to 4 decimal places. Okay, 0.0805. Plus what could possibly be equal to 1, right? So we have about 8 pennies here, right? So I'm expecting this to be about 92 pennies. Okay, so this question mark here, that is 1 minus 0.0805. Biggest mistake people make on this is to not get the correct, right? Not get the correct decimal place there. Remember, this is $1 minus 8 cents, plus a little bit more. Okay, so what we're going to do is we'll get on our calculator. Okay, 1 minus 0.0805. Okay, 91.95, so about 91.92 cents. That's what we want. Okay. So this is the probability that 7 through 16 of the people decided to use their phone for a purchasing decision. Okay, so 91.95. 0.9195. Okay, 7 or more. What is the probability that fewer than 8 Fewer than 8 use their phones. So we have to recalculate. Okay, so fewer than 8. Is 8 fewer than 8? I don't think so. I think 7 is fewer than 8. I don't think 8 is fewer than 8. So we have to do 1, 2, 0, 1, 2, 6, 7. These are the numbers that are few. These are the values that are going to be fewer than 8. These are, we have fewer than 8 people. So that's how we're going to do that. So that's going to be Binomcdf. Okay, and we're going to have 16 folks, 0.58, and then 7. We aren't going to subtract from 1 this time because of this word here. It says fewer than. When it says more than or greater than, then we're going to have to subtract from 1. Fewer than, that's okay, from 0 up to whatever we want. Okay? I don't think your book says between, so we don't have to worry about that case. Okay? So what we're going to do is we're going to say Binomcdf. So here's distributions. Oops. Okay, we're going to go to the CDF one. Okay, and again, there are 16 of these folks that are checking their phones, right? They have a 58% chance of 58% chance of doing so, and we are going to say fewer than 8, which would be 7. Okay, be careful with the English. That's really the goal here. Okay, and our answer here, right? 0.18318. Okay, so this was 0.18318 and some other stuff, but to 4 decimal places, that's going to be 0.1832. Okay, so about 18%. Okay, 0.1832. Zero 0.1832. Okay. The probability that exactly 9 of them. So here's another key word, right? Exactly 9. So we can use a particular value. We want 9. All right. So we're going to look on part C here is going to be Binomcdf because we want that particular value of x equals 9 or r equals 9. All right, so we're going to do Binomcdf. How many folks do we have? We have 16 folks. What is their probability of success? Is 0.58, and we want 9. Okay, we're just going to type that in. By the way, if you're ever, if we have to do this on paper and send it in, this is how I want to see you write out your problem. Okay, I want you to write out, this is what I typed into the calculator. All right. So that's going to be second function there. So we're going to have PDF, okay? And then, because this tells me at least what you meant to type in. Even if you didn't make it, this at least gives me a way to grade you to say, well, I knew you meant to type in this one. All right. So Binomcdf, because that's particular, we have 9. Boom. There we go. 0.19589. 0.1959 is going to be our answer. So this is 0.1959. Okay, there we go. 1959. All right. So exactly 9. 1959. All right. Would it be unusual if 11 or more use their phones for guidance? Okay, so unusual means that the probability is less than 5%. Okay, so we have to figure out what's the probability that 11 or more did this. Okay. Oh wait, sorry, I misread this. Would it be unusual? Oh no, if more than 11. Okay, so we want what's more than 11? 12. Okay, and then what's not that? So that's 0, 1, 2, 10, and 11. Okay, So we're going to use a CDF this time, a cumulative function, because we want that collection. Okay, we want this collection of probabilities. So Binomcdf, okay, we want 16 people, 0.58 up to 11. Okay, so we're going to go ahead and check. We're going to say Binomial Distribution, Binomcdf. Boom. Okay, we have 16.58, comma, up to 11. Okay. So let's see, this was 0.8706 what? 0.870668. Okay, to 4 decimal places, this 6 turns that into a 7. So this is 0.8707, right? But what did the question ask? The question asked for more than. So we want 1 minus 0.8707. We should get 1293, I think. Point. We'll double check. 1 minus 0.8707, 1293. Beautiful. All right. So it would not be unusual because it is 0.1293. Fingers are crossed here, so we're checking our answers. That's pretty good. All right. Next one up. And the reason I say that is because it's so easy. Like, what if I typed in this when I didn't mean to? Okay, that's why I want you to write it down, because it's so easy to enter something like that, or 7807. It's so easy to do that off the calculator that if it wasn't in a timed area, or if there's a chance for you to recheck your work a couple of times, like a day later to check your work, you would catch all of these errors. So I don't, those kind of depend. All right. All right, national survey reported that 30% of adults in a certain country have hypertension, high blood pressure. Sample of 20 adults studied. Round the result to at least 4 decimal places. All right. So we have probability, right? We have how many people, and is equal to 20. Okay. Our chance of success. Right. So realize that our chance of success is having high blood pressure. Every nurse that is now listening to me is screaming, no, that's not right. But that's what we're trying to figure out, is how many people have it. So that's our success. All right. So in the first section, right, our first section, we're going to have probability of exactly 4. Well, that's a particular number. So we're going to say Binomcdf. We want 20. We want 0.30. What was the number we were looking for? It's going to be 4. Okay, this is going to be a small number. Okay, so we're going to go to second function, distribution. Binomcdf. We have 20 folks here. We have a chance of success of 0.30. And our number of successes we want is 4. That was a lot higher than I thought. Okay, so 0.1304. Usually your single values are pretty small. Okay, you have to do like cumulative stuff to make a number that seems reasonably large. Okay, 1304, 0.1304. 0.1304. Okay, about 13%. What is the probability that more than 6? More than 6. Well, what numbers are more than 6? 7, 8, 9, ... up to 20, because that's our sample size, right? So what we're going to do is we're going to say 1 minus Binomcdf CDF because we want the collection from 0 to 6 in order to get this amount. Okay, so we have 20 folks. We have 0.30. Okay, 30% of the population had high blood pressure. Oops, what do I want to do? I want to do this. 0.30, and we're going to go up to 6. All right, double checking more than 6. So we're going to go up to 6, and then 1 minus this. Okay, 1 minus this bit is going to give me the rest. Okay, you can even do that in the calculator in one step if you want to. Watch. 1 minus second function distributions up to Binomcdf. And we're just going to type these numbers in. 20, comma, 0.3, comma, 6. All right, so that's what we're doing here. Okay, we got 0.391990 to 4 decimal places. 1, 2, 3, 4. So this 19 here is going to turn into a 20. Okay, so 0.3920. Okay, so we're going to say 0.0 or 0.3920. So that's the probability that more than 6 people in this area, right? 30% of the people have hypertension. What's your chances of finding more than 6 people with hypertension? It's about 40%. Okay. So let's see. What is the probability that fewer than 3? This one says fewer. There's no 1 minus. Okay, fewer than 3. So what numbers are those? Well, that's 0, 1, and 2. We don't really technically need the CDF for this one because it's only 3 problems. And they're not too bad, but we'll continue reinforcing the calculator here. Fewer than 3. So what we're going to do is we're going to do Binomcdf, right? We have sample size of 20, 0.30, that's our chance of success, and we are going to fewer than 3, 2. So the CDF part, right, that's going to count, 0, 1, and 2. All right, well, let's see what that equals. Okay, it says fewer than, so we're not doing a 1 minus problem, it's just, there it is. All right, CDF, 20, 0.3, and 2. We have 0.035, 0.03548. 1, 2, 3, 4. So this 8 is going to turn that into a 0.0355. 0.0355. 1, 2, 3, 4 decimal places. All right. That's going to be my answer. Okay, so that's less than 5%. Right? That's 3.5%. So if they ask me if this were unusual, I'd say yes, it is, because we're less than 5%. Right? We have 3 pennies here, 3.5 pennies. Would it be unusual if more than 8 had hypertension? There's a more than here. Okay, more than 8. Well, what numbers are more than 8? 9, right? 8 isn't more than 8. So because it has more than, we're going to say 1 minus. Okay, if it was less than, it would just be regular. It's more than, so we have 1 minus. Binomcdf. It's 20 total people, chance of 30%. We're going to say we want more than 8. So what numbers are not more than 8? Is 8 not more than 8? Was 8 more than 8? 8 isn't more than 8. So here we have 0, 1, 2, 6, 7, 8. Okay, these are the numbers that I'm going to calculate because 1 minus this, right? 1 minus this probability is going to be more than 8. Okay, so that's how we'll type that in. Okay, so we want 1 minus second function distribution, CDF, we're going to do 20, comma, 0.3, comma, 8. And we ended up with 0.1133. So in this case, it'd be 11.3%, right? About 11% that more than 8 people are going to have hypertension in this country. Okay. Or whatever country they wanted them to set up here. So 0.1133. All right. My answered. So let's see. Put our fingers crossed. Please select an option. Oh, would not be unusual. Thank you very much. Why wouldn't it be unusual? It's more than 5%, right? 11% is a bigger number than 5%. So that's why it would not be unusual. Okay, that's all they want you to know. Is like, well, is it bigger or smaller than a nickel? Okay. This is a little bit more than a dime. It's bigger than a nickel. Okay, number 9. We're almost there. So in a poll about work, 70% of the respondents said their jobs were sometimes or always stressful. 11 workers are chosen at random. Round the answers to 5 decimal places. All right. So what's our setup here? We have a total of 11 people. We have a probability of success of 70%. Okay, and again, you could argue, like, is that really a success? Like, yeah, because that's what we're studying is probability-wise. Okay, we want 11 people chosen at random. So part A, what is the probability that exactly 10? That's a particular number. So we want Binomcdf for a particular, right? We're going to have 11 people. We have 0.70. What is the number we are interested in? 10 of them. All right. Doesn't say 10 or more, doesn't say less than 11, it says exactly 10. So that's why we're doing it this way. All right. So what do we have here? We have second function, distribution, Binomcdf, right? Probability density function, or particular, however you want to do it. Okay, we're going to say we have 11 people here. My probability of success is 0.7, and we want 10. All right, about 9%. Okay, so what are we going to do here? We're going to say this was 0.0932. Okay, so 0.932. All right. So we have probability of that more than 8 people find their job stressful. More than 8. What numbers are more than 8? 9. 9 is more than 8. So 9, 10, and 11. Okay. So what we're going to do is, because we have a collection now, we need the binomial CDF. Okay. So what we're going to do, it says more than, so 1 minus binom CDF, and we count up to a certain number. Here we're going to count up to 8. So we're at 11.708. All right. And that's going to give us our solution for this. So it's 1 minus binom CDF, right? We have a total of 11 people. That's never going to change. 0.7. And then we have up to 8. All right. We ended up with 0.31274. Since we're rounding to 4 decimal places, we could drop this 4 because 0.30, I'm sorry, 0.3127. Okay. 0.3127. Okay. So this problem might be useful in determining, like, you wanted to offer, your HR department wanted to offer counseling, or maybe if a certain percent gets too stressful, they decide to hire some more people. Maybe they send people to a therapist, whatever. Okay, so what is the probability that fewer than 4 find their job stressful? Okay, so we want C is fewer than 4. So it's fewer than, so we could just do a straight binomial C, D, F. It says fewer than 4. Is 4 a number that is fewer than 4? I don't think so. I think the numbers that are fewer than 4 would be 3, 2, 1, and none. Okay, so since my cumulative distribution will already count that without any modifications, we're just good to go. Okay, so we want Binomcdf 11.7. What are we counting up to? We're going 0, 1, 2, and 3. We're going to put up 3 here. Okay, so we're going to say second function binomial. All right, we have 11, comma, 0.7, comma, 3. This will count up to 3. Right? And they want to fewer than 4. So there we go. Okay, 0.00429 and some more zeros. So it's 0.0043. So this is 5% would be here. Okay, this is less than 1%, right? This is almost 0.5%. Okay, so fewer than 4 in this group. Okay, fewer than 4 find their job stressful. Not very much. Okay, so this was 0.0. Oops, just 1 point. 0.0043. There's my 0.5%. Would it be unusual if 6 or fewer? Oh, sorry, not 6 or fewer. Fewer than 6. That would be 5. Okay, so fewer than, we don't need to subtract because we only have to do that for more than. Okay, so we want binomial C, D, F. We have 11 total. We have a 70% chance of success, and we want fewer than 6. What numbers are fewer than 6? These numbers are fewer than 6. Okay, so Binomcdf always starts from 0 up to the number that you tell it. Okay, so in this case, that's okay. 0 to 5 is just fine. Right? Second function. Okay, binom. With binomial CDF, we have 11 total people. We have 0.7 chance of success. Okay, 70% chance of success. And we want to know for 5 people. Okay, so 11, comma 0.7. And again, your TI-84 calculators are a little bit nicer at guiding you through this, so you don't have to have this memorized. But if all you have is a TI-83, I'm sorry, this is what we have. 0.07822, 4 decimal places right here. This 2 is not contributing, so it's 0.0782. 7%. Okay, 0.0782. Is this less than 5%? No. Less than 5%. So it is not be unusual if fewer than 6 of them found their job stressful. All right. Let's see. That looks pretty good. All right, last one. More stress. All right. Actually, I don't think we need to do this one. I think we'll be okay. So, oh, no, we do, because we want the mean and the standard deviation. Okay. So this isn't a probability, this isn't necessarily a probability question. This is a mean and standard deviation problem. So in this case, right, the number of people was 14. Okay. The probability of success, this was 0.57. Okay. That was gotten from up here. 57% said the jobs are sometimes or always stressful. So that's our success. Okay. And they want to know what is the average. Okay. Which is n times p. So we have 14 times 0.57. How many decimals did they say? 2 decimal places. Very good. Okay, and this is equal to 14 times 0.57. Okay, 7.98. Almost 8 people. Okay, the way they use this thing is like, you know, if HR actually, you know, if HR wanted to care about their employees, they might say like, you know, in this section, we're going to have almost 8 employees that experience high levels of stress. So if we have to have a counselor on staff or on site or something, this would be like, you would be able to say, well, we maybe only need like one that's going to work part-time because we only have 8 people that might have to come in for a weekly session. Okay. So you would use these things in like a more global sort of a way. Okay, so with that 7.98, you usually deal with companies that have like hundreds or thousands of people on them. You're going to need the decimal places. Okay, we're not trying to say that almost 8 people. Okay, we're saying that on average, that's what's happening. Okay. Standard deviation. Okay, again, don't memorize this formula. Look it up when you need it. This is the square root n times p times 1 minus p. Right? If your long-term goal is to be like a high school teacher that teaches statistics, not all of them do, you could memorize this formula. But unless that's your career goal, okay, I wouldn't recommend it. You can be a college teacher that teaches statistics too. There's more of those. Okay. Something costs 57 cents. You pay $1. How much change do you get? Right? 43? Nah, it's too little. No, it isn't. It's right. So times 0.43. Square root. And there we go. All right. So 14 times 0.57 times 0.43. All right. So that's our, we didn't take the square root yet, right? So we have the square root of 3.4314. And now what we're going to do is we're going to say second function square root, second function, our previous answer. Bang, there we are. So how many decimal places do they want? 4 decimal places. Very good. So we want 1.8524. So 4 decimal places, that's here. So 1.8524. All right. 1.8524. Okay. So there we go. Let's check. All right. Hooray. That was worked out. So I probably not ask you this particular question, part B. Part A, I probably would, but part B, I would not. All right. So there's our binomial distribution section, and you know, you're halfway. You know, if you get through this, 6.1, 6.2, chapter 7, those are the harder chapters. So if you're getting through this, you're doing a great job. Keep it up. You're almost all the way through it. Okay, you can get through this hump, chapter 6, chapter 7. The rest of the class is a bit downhill from there. Okay, so good luck with this. Do your homework, and we'll call an end to this.